Hi, I'm Seth, and I'm going to briefly walk you through some key terms that you'll need to know if you're new to statistics. The first of these being statistics. Statistics is an entire field of study in and of itself, but we use it in the social sciences. I like this definition from D. Michael Thorne, a set of techniques for organizing and analyzing numerical observations, basically. So what that means is methods for making sense of groups of numbers. Now, you'll also see this term used to refer to any numerical summary of data. So if you calculate the average number of hours of sleep that an American gets in a night, that's a statistic. Now, you might wonder where these numbers come from. In the social sciences, they are measurements. I like this definition from S.S. Stevens, which is lightly paraphrased by Patrick Curran as the assignment of numbers to observations in some principled way. So you observe some phenomenon in nature and you assign a number that helps you make sense of it or understand it. In the social sciences, these measurements are often self-reported. So to make this a little more concrete, suppose you're completing a personality test online and you see a question that says, mark the extent to which you agree or disagree with this statement. I like to go to parties. And you can mark anywhere from a 1 for strongly disagree to a 5 for strongly agree. What's happening is you're sort of introspecting about what you know about yourself, and a number sort of bubbles up to the surface, and that's what you say. And that number is representing your understanding of how much you like to go to parties. Now, this series of videos is not really going to be concerned with measurement. We're just going to assume we've already got reliable numbers from somewhere, and we're just going to be dealing with how to make sense of them once we've got them. Another basic term you're going to see a lot is data. You're probably already kind of familiar with what this means. But in this context, you can think of it as a collection of measurements. Now, I'll say measurements sometimes, I'll say scores. These are just numbers that represent our observations. In the social sciences, we like to represent our data in columns and rows. So here you can see an example. We have several different subjects, and we have different scores for their sociability and anxiety. In psychology, our cases, the things we're observing, are often individual people. So each row represents a different person's scores. A variable is any characteristic that can take on different values for different cases. So as you look down that column for sociability, you can see different people that we've measured have different amounts of sociability. Subject 2 has a score of 4, whatever that means. Subject 3 has a score of 15. And this represents how they are more or less sociable than each other. Now, we study all sorts of different variables in psychology. The point to remember is these can take on different values from one person to the next. They are not constant. Another term that you're going to encounter a lot, and which there's sometimes confusion about, is the term effect. Now, this is an unfortunate choice of words because a statistical effect does not necessarily imply causality. It doesn't mean that one variable is caused by the other. This term gets used really anytime we're describing a relationship between multiple variables. So, for example, does this treatment have any effect on patient symptoms? What we're asking there is there a relationship between whether or not you get this treatment and how many symptoms you show, or what kind of symptoms are observed? Another example would be looking at the link between smoking and lung cancer. So you might be interested to know, is there a relationship between whether or not someone smokes, or how much they smoke, and whether or not they have cancer, or how severe the cancer is? A third example, which may not seem completely intuitive at first, is looking at whether or not there is a difference between groups on some variable that we care about. Now, it may seem strange to say that looking for a difference between two groups is the same thing as looking at a relationship between two variables. So let's visualize this. On the left, we have a scatter plot between two continuous variables. You'll learn more about scatter plots later, so don't stress about this too much. The main thing to take away is that you can kind of see a downward trend. That's represented by that downward sloping line. As we go from left to right across this graph, the data points are kind of trending downward. What that means is that as your predictor variable is going up, as scores on that get higher, that's represented on the x-axis, the horizontal axis, scores on the outcome variable, represented by the y-axis, the vertical axis, those scores are going down. So this is a negative relationship. As x goes up, y is trending downward a bit. And it really doesn't matter what the variables are. We're frequently going to be saying x for a predictor and y for an outcome. So just kind of get used to that. Now that tends to be pretty intuitive to people, but the graph on the right also is showing an effect. So what we have here now on the x-axis is group membership. So the cluster of data points on the left, those scores come from individuals in group A. The cluster of data points on the right come from individuals in group B. In this case, the line that's connecting these two clusters is going from the mean of group A to the mean of group B. You'll learn more about the arithmetic mean later, but it's basically what you probably think of as the average. So in this case, the line is representing the difference in the average score for group A and the average score for group B. And in this way, this plot is showing a relationship between what group you're in and what your score is on this outcome variable. So if you've only got two variables, one way to think of a statistical effect is what is happening to the outcome variable as we move from left to right across the graph. So on the left case, the data points are sort of trending downward as x increases. On the right, as we move from group A to group B, there's a slight increase in whatever that outcome variable is. Okay, so that is a quick overview of a few introductory definitions that you'll need for statistics. Let me know if you have questions.